In the lecture last Monday, we were discussing carbohydrate nutrition and utilization. And I might just put an outline of the general form that I'm going to follow here. First, we're going to talk about seasonal changes in carbohydrate. And that'll be both in the dormant season and I'll put this outline. Did you want to make an announcement?
Yeah.
Or? Okay.
There are 3 exams here that come this morning. Picked up Perez, Brenner, and Wayne. Picked them up after class. Did you announce this at all?
No.
These are the old and new grades on the true and false quiz. You want to look at them, if you're in a hurry to look at it. The 8H again will be over here. J2R here, and the S to W here. And then they'll be posted outside my door if you want to look at them later. Okay, about the midterm. In the discussion yesterday afternoon or Monday afternoon, we had a couple of points that came up. One was on the question concerning what's the main reason for determining the distance between rows. And we graded it for equipment only. But it could be cost, because we emphasize cost a lot. So any of you put down cost and lost 2 points on it, either see me or Frank Dolly in lighter leather in 2004, and you get it changed. Also, on the one about soils, some of you gave shallow soils and poorly drained soils as 2 different reasons, and they were only graded as 1 point. That was graded to the same answer. It should not have been. So some of you lost 2 points on that basis, where you put shallow soils and poorly drained soils, and it was marked as equal or the same. You pick up 2 points.
What question number was that?
I don't know. You have your blue book, don't you? And I think you bring you. How many points did you lose on that question we're arguing about yesterday or Monday? What? That question about zones. 5 points. Turn your book in. Now I want to collect those either your papers or your answers in this reading this take-home exam. Name on it. You sure you got your name on it?
Okay, let's continue with the lecturing. Now, the last lecture I gave you some values for the seasonal changes in the carbohydrates that occur in different parts of the grapevine between their high and their low. And you noted that there was a change in some tissues from 22% down to 6 to 8% in a period of 1 or 2 months, indicating that during this period of rapid growth, there's as much as 8 or 9% utilization of carbohydrates per month during this grand period of growth. Now, during the dormant period, the carbohydrates are utilized very, very slowly. The work that Dr. Winkler did, where he made a balance sheet estimation of the carbohydrates that were being used, indicated a loss of about 0.5% during the dormant season. That's mainly during the months of December, January, and February. This is in the above ground parts of the vine now. So, and this was contributed to respiration losses of about 0.5% per month. Now, this is pretty minor compared to this 8 or 9% loss in carbohydrates during this period of April and May when the new growth is occurring. In the roots, there was a greater loss, up to 1.5 to 3% loss in carbohydrates in the roots, and this is contributed to the fact that root temperatures seldom go below 45 to 50 degrees Fahrenheit, and they're still This would mean that the respiration would be higher at these temperatures, and there's also a little bit of growth occurring at this temperature too. So this would account for the greater loss of carbohydrates during the dormant period in the roots compared to the above ground parts. Now we said the carbohydrates are present in the vine mainly in the form of starch, sugars accounting for only about 1 to 3%, except during the cold winter months when there's this hydrolysis and this interconversion of starch to sugar where the levels may reach 8 to 12%. But other than that, the sugars, the sucrose, and the reducing sugars are present in levels of about 1 to 3%. Now, I'm going to talk about spring utilization of carbohydrates, and this begins usually in late February, early March. This is the first stages of cambro activity occurring at this time, before bud break. And the carbohydrates in above ground parts are first utilized in the bark tissue. The bark tissues in the canes, in the trunks, and then in the roots are utilized before the woody tissues. You might show that like this. If this is the trunk of the vine, here you have a cordon coming out here. Here's an arm, and then a spur on that arm. The carbohydrate, and then you have two buds on that spur. This is now in spring, and at the end of March when there's new shoot growth is first beginning to grow. The carbohydrates, or the loss of carbohydrates, is first in this bark tissue here in the spur, or in the spur, then in the arm, and then in the cordon, and then it progresses down along the trunk, and then finally the carbohydrates in the bark of the roots are utilized. Then the next carbohydrates that are used are in the woody tissues near the site where that bud is growing from. And then the woody tissues in the trunk are used, especially the 1-year-old woody tissues are used first. Then the woody tissues are laid down in rings, 1 year, 2 year, and so forth, and it's usually the newest laid down carbohydrates in the trunk that are first utilized. The carbohydrates in the roots seem to be last utilized, and this was shown on Dr. Winkler's graphs, where there was still quite a bit of carbohydrates in the root tissues, even in June and July, when the carbohydrates in the cane tissues were at a very low level. Now, a leaf will require photosynthate up until it's about 1/3 its maximum size. In other words, it's a parasite on the parent vine until the leaf is about 1/3 its maximum size. When the leaf is between 1/3 and 2/3 its maximum expanded size, it more or less holds its own. It imports about as much as it exports, between 1/3 and 2/3 its maximum size. And then between 2/3 and after it's 2/3 or more fully expanded, then it's only exporting carbohydrates. So until that leaf is 1/3 its fully expanded, it's completely dependent, or almost completely dependent, on the parent vine for its source of carbohydrates, and it's drawing on the reserves in the tissues of the trunk and canes and roots for its growth. And this usually is about 2 to 3 weeks after bud break.
What is 2 to 3 weeks after bud break? Is that?
Well, bud break is about.
But what is it when the leaf is fully expanded?
No, the leaf is only about 1/3 its maximum size. It takes about 5 weeks for a leaf to become fully expanded. So 2 to 3 weeks, it starts to grow very slowly, and about 2 to 3 weeks after bud break, it's about 1/3 its fully expanded size. And in general, the carbohydrates reserves are used, as I said, most completely from the bark tissues and from near the vicinity where the shoots are growing from. Utilization of carbohydrates in the bark and in the woody tissues are much more completely utilized here as compared to, say, the trunk. This can perhaps be illustrated by a couple figures. If we compare the utilization of carbohydrate in the woody tissues of the trunk, this is one-year-old wood, 2-year-old, and 3-year-old wood. The utilization was 55% here, 35% in the 2-year-old wood, and 25% in the 3-year-old wood. This is in the trunk. This is in the trunk tissues now. So roughly a half of the carbohydrates were utilized in the 1-year-old wood, about 1/3 in the 2-year-old, and about 1/4 in the 3-year-old trunk wood. So the trunk does serve as a source of carbohydrates, but much of this carbohydrates doesn't seem to be available for growth. There was some studies done by Dr. Weaver and another student several years back where they were looking at overcropping on Alicante brochet vines, and they completely overcropped the vine and even killed the vine, and there was still about 8% carbohydrates in these vines. So there's a certain amount of carbohydrates in the vine that doesn't seem to be available for growth. Now the question is often asked, are the carbohydrates stored in the bark and in the woody tissues available for sugar accumulation in the fruit? In other words, does the sugar accumulation in the fruit, does it come from these storage carbohydrates, or is it completely from the photosynthate that is occurring by leaf photosynthesis? And the answer to that is normally the carbohydrates stored in the woody storage tissues and in the bark are not transported into the fruit for sugar accumulation. They can be available, though, under certain stress conditions. If you completely defoliated the vine, for example, under this situation, or if you had a very heavy overcrop situation, some of this carbohydrate in these woody storage tissues and bark can be transported into the fruit. But normally, if the vine's not overcropped, if there's no serious insect infestation where they've lost leaf area, there's no movement of carbohydrate from these storage tissues into the fruit. This was demonstrated. We did a little experiment several years back where we took all the leaves off of the vine at veraison. This is the point when the fruit first begins to soften and change color. And completely stripped all the leaves off and kept all the leaves off at that point, and just to see how much sugar could accumulate in that fruit. And it went from about 8% sugar up to 14% sugar without any leaves. But this is a very unnatural situation, and normally you don't get this accumulation of sugar in the fruits from the storage tissues. Now, let's look at the storage or the accumulation of carbohydrates in the grapevine. And I think this is best illustrated on this graph that I have drawn on the board. And this same graph now, by the way, is in this reading assignment on page 92. I think it's on page 91. This exact same figure is in your book. And I would strongly suggest that you read and study those 2 or 3 pages very closely, because there's some very important relationships that are show in this figure. And you're undoubtedly going to get a question or two from this. Now, The carbohydrate well, let's look at this figure here now. This figure here, this line curve shows you the accumulation or the utilization of carbohydrates during the annual growth of the vine. This is carbohydrate in the cane tissue. And it's at its high here just before bud break. If you wanted to continue this on back, it would be pretty much level through here during the months of January, February. Then after bud break, it begins to decrease very rapidly during this period when growth is occurring very rapidly. During this grand period of growth, there's a rapid utilization of carbohydrates, reaching a low here in middle of June, first part of July. And then at this point here, the rate of shoot growth is beginning to decrease. In other words, the rate of shoot growth reaches its maximum rate of about an inch or an inch and 1.4 inches per day during this time here in May, first part of June. Then it begins to decrease, and about that time that the shoot growth begins to decrease, this is the first point where carbohydrates begin to increase in the shoot tissues, in the new shoots, or in the cane too. With the cane then is becoming a 2-year-old tissue then. So at the time when the shoot growth begins to decrease, this is the time when the carbohydrates begin to accumulate in these tissues. And the carbohydrates on a shoot first begin to accumulate in the middle part of the shoot. In other words, if you draw a shoot here, the carbohydrates first begin to accumulate here in the middle of the shoot and then progress in each direction. This is again from this study of Winkler and Williams, where they analyzed the levels of carbohydrates in the shoot, and they sectioned it into basal, middle, and terminal sections, and they found that the carbohydrates first begin to accumulate in the middle part of the shoot and then towards the base and towards the terminal part of the shoot.
Is that pivoted around set? That graph more or less?
Yeah, well, now that's right. Bloom is occurring about right here. At about the time that the shoot growth begins to decrease, this is also the time of bloom, and it's also the time when fruit bud initiation is beginning. And it's important that you have your shoots in a stage where they're beginning to decrease their rate of growth, because if that rate of growth is still, if this curve was moved in this direction and still was continuing very rapidly, they would then be competing for carbohydrates, and fruit bud initiation would be reduced, or your fruit set would probably be reduced. So if you happen to put on, say, a heavy application of nitrogen right here before bloom or something, and you encourage these shoots to grow very rapidly, put on an irrigation, usually you find that your bud fruitfulness is quite low that next year, and your fruit set is poor too. Yeah.
Has that change been regulated with enzymes?
That's the theory, that this, although nobody has proven this one way or another, but the hypothesis is that this rate of growth is somehow regulated by plant hormones. And I think it's pretty reasonable to expect that the ratio of gibberellin and these auxins and kinases and so forth are pretty well regulating the rate of these growths. Berry growth, now, if you wanted to put berry growth in here, it would be starting about here and then coming up and leveling off like this. Actually, I didn't draw that berry growth curve quite right, because there's a lag phase right in here. It goes up and then lags a little bit and then continues on. So the utilization of carbohydrates here in the shoot can be thought really of 3 different stages. There's a rapid utilization stage, the stage until the leaves are 1/3 fully expanded. occurring mostly during the month of April. So there's this period of rapid utilization is one stage. And then there's a second stage where the shoots are in their self-support stage, between when the leaves are about 1/3 to 2/3 fully expanded. And that's a pretty short period of time, usually only 2 or 3 weeks. So there's this one period here, and then there's this second period where there's I refer to it as a self-support period, where the amount of carbohydrates being exported is about the same amount as that being imported. And then there's the accumulation period, which occurs from flowering on. Now, there's been a little bit of work. A student of mine, Mr. Amadula, has been doing a little bit of work along these lines, and also another student, a postdoctoral, was here a few years back. We asked ourselves the question of, are the last carbohydrates that are photosynthesized by the plant in the fall, before leaf fall, are these carbohydrates the first to be utilized in the spring? And this was very easy to determine by just putting on some radioactive carbon dioxide during the fall months and letting this carbon dioxide being photosynthesized and laid down into the woody tissues, and then looking at its utilization the following year. And it's indeed true that the last photosynthate that is produced in the fall is the first to be utilized the following spring. Now, there are at least 4 different factors that can affect the rate of accumulation of carbohydrates in the storage tissues of grapevines. And I think probably most of you could probably list these without even being told, but of course one of these is the amount of crop. If you have a very heavy crop, this is going to affect the amount of carbohydrates that's going to be stored in the vine. A second factor is the status of the shoot growth. If, like I mentioned, if you have a very heavy nitrogen situation in the soil, which encourages luxuriant shoot growth, this is going to affect the amount of carbohydrates being stored in the vine. And if the situation is such that it encourages shoot growth to occur late in the summer, if you have a lot of water in the soil and the very fertile conditions, this too tends to reduce the carbohydrates that are being stored in the vine. In other words, all the photosynthate is going into shoot growth and a little is going into carbohydrate storage. Climatic conditions will affect the rate of carbohydrate accumulation. As you can well reason out by these graphs that I showed you earlier, that if you have rainy, cloudy day, you're not going to have as much photosynthesis and you wouldn't have as much carbohydrate being stored. And the leaf exposure to light, the trellising system itself, will affect the amount of carbohydrates being stored. If you have all your leaves exposed to good light and full sunlight, they will be capable of storing more carbohydrates than if you have a system where much of the leaves are in the shade. Okay, those are 4 factors at least that affect the carbohydrate storage. Question?
If you're getting a lot of shoot growth, then you're getting a lot of storage also.
Well, you want a lot of shoot growth up until this time of flowering, because you want a lot of leaf area. It's true if you have a lot of leaf area, you have the capability of storing more carbohydrates. But if this shoot growth is continuing late into summer, then most of your photosynthate is going into producing vegetative growth, and little is going into storage. So you want this shoot growth to start reducing its rate of growth after about the time when flowering begins. Yeah.
Would it hurt your position if you promoted Grape, promoted shoot growth as much as you could up until the point where the berries start to soften and ripen up? Would that be extending too long?
Up until the berries begin to start ripen,
Start soft?
softening. Well, no, I think if you have very luxuriant shoot growth going at bloom time, then the likelihood of you're going to affect fruit set then. And you want that rate of shoot growth to start to decline by the time of flowering. Because if I'm going to discuss that right now, if the shoot tip continues to be the most powerful sink on that vine, it's then competing for carbohydrates and taking away what could be going into the flowers, and this would affect set. Well, there was a fellow from Australia that worked on a PhD thesis here around 1960, and he did a very nice work on studying the translocation of photosynthate or carbohydrates in vines using radioactive labeled carbon dioxide. And his work can be more or less summarized by these figures that I have on the board here. And this is this relationship that I think I mentioned to a couple labs already, the source-sink relationship. The source, this is used by physiologists to explain translocation patterns. And the source, in this case, being a leaf. The leaves are, of course, the source of photosynthate, a leaf that's at least 1/3 or more fully expanded. And the sinks are then any part of the vine that require photosynthate. The shoot tip being a sink, the roots being a sink, the parenchyma tissue, storage tissue for carbohydrates are a sink. So any part of the vine that requires carbohydrates is a sink. And in this work, he labeled various leaves on the shoot and looked at where the photosynthate was going at different stages of vine growth. And during the first 2 or 3 weeks after bud break, all of the photosynthate was going upwards. In other words, shoot growth is occurring very rapidly, and the terminal or the shoot tip here is the strong sink for the first 2 or 3 weeks after shoot growth. Then for the next 3 to 6 weeks, there's photosynthate that's moving in both directions. These leaves that near the terminal part of the shoot transport photosynthate towards the apex of the shoot, while the basal leaves, first 8 or 10 leaves, were transporting photosynthate. Some photosynthate was going into the cluster, forming the cluster framework. Some was going out of the shoot into the cane and into the parent trunk and into the vine, into the roots. So that there is movement in 2 directions here between 3 and 8 weeks after bud break. These apical leaves moving photosynthate mostly to support the shoot tip and the new growth there. The basal leaves moving photosynthate into the cluster and into the storage tissues of the parent vine. And after about 8 weeks is about when bloom occurs. And I should also mention at bloom time, this was a very important finding that they found in the study, that the cluster during the bloom is a relatively weak sink. The apex was a stronger sink than the flower cluster at bloom time. And this is one reason why in Europe they have a common practice of tipping the shoots here at bloom time to divert the carbohydrate that would be going into that shoot tip into the cluster. And they have, in fact, shown increased fruit set by this tipping operation. This is not used in California, since we generally find fruit set is well enough under California conditions. But in Europe, where they have a lot of cloudy, rainy weather, they found that the shoot tipping operation can increase fruit set. And it's a very critical operation. You must time it exactly right. But if we remove that shoot tip at the right time, you can divert photosynthate from the shoot tip into the cluster and improve your fruit set. If you did it too early, all you do is start the basal or the lateral buds here from growing again, and you haven't done anything. But if you do it about a week, a few days up to a week before bloom, then you can increase the fruit set. Then after fruits, this period after fruit set to harvest, the cluster then becomes a very powerful sink, as well as the parent vine. When I draw the arrow here all the way down to this cane here, it means that photosynthate is going not only into the cane, but into any storage tissues into the parent vine. So at this stage now, the cluster is a more powerful sink than the shoot tip, and the parent vine is also a pretty big sink. And also at this stage, we have photosynthate that it can move in two directions here. We have these basal leaves that move photosynthate up to the fruit cluster, as well as moving photosynthate out into the parent vine. So there can be photosynthate being moved in two directions here in these shoots. And also note that here there's also a few leaves, two or three leaves, that are capable of moving photosynthate in two directions. There's a place here on the shoot where some photosynthate can go to the shoot tip as well as to the parent vine. And this is continually changing now, because when a few more leaves unfold and expand, then this arrow continues to go up, and more of these leaves are putting photosynthate down into the parent vine. Now, after harvest, almost all the photosynthate is being moved out of the parent vine, out of the shoot into the parent vine. A very small amount might go into the shoot tip at that stage. But this is the important time for the vine to replenish its carbohydrate levels for next year, and almost all the photosynthate after harvest goes into carbohydrate storage. So if you happen to have a very heavy crop where you harvested late, and then on top of that had a early frost, then you haven't allowed that vine to accumulate carbohydrates, and it's really going to be suffering the next year. Now, there was some additional work along these lines that a fellow in Switzerland did, Professor Koblet, and he did this similar type of work, and his data more or less confirmed this data here. But in addition, he did some work where he indicated that the lowest 8 to 10 leaves are mainly responsible for the fruit buds initiation and also for the cluster framework, the formation of the cluster framework. So the basal 8 to 10 leaves are necessary for fruit bud initiation and for the formation of the cluster weight or framework. And then he also found that the leaves above about the 10th node are mainly responsible for the sugar accumulation in the fruit. Now, it's not an absolute thing, but this is what his conclusions were, that the basal leaves are mainly responsible for forming the structural, the framework of the cluster, and also the fruit buds that are initiated at the base of these leaves. And then the leaves above the 10th or 12th node are mainly responsible for providing the cluster with sugar. And there was another experiment of small strains that more or less confirmed this, where they removed all the leaves off the basal part of the shoot and all the leaves off the terminal part, half of the shoot, and compared the carbohydrate levels in the fruit, and they found that leaves removed from the terminal part of the shoot affected the soluble solids or the bricks content of the fruit more than the removal of the leaves off the basal part of the shoot. So that pretty well confirms the work here of this Swiss worker. Now let's go on and talk about differentiation of fruit buds. And as you know from your lectures you had last quarter, that the buds in a grapevine may either be leaf buds or fruit buds, a leaf bud being a bud without a fruit cluster. And whether a bud undergoes differentiation and forms a cluster primordia is associated with the carbohydrate cycle. In other words, whether there is adequate amounts of carbohydrate being stored in the shoots. Now, we really don't understand this, we don't really understand the mechanism how carbohydrates affect fruit bud initiation, but this has repeatedly been found that when you have conditions that favor high carbohydrate accumulation, you generally have very fruitful buds, or buds that have fruit clusters. So factors that favor carbohydrate accumulation also favor fruit bud initiation. Now, I've mentioned some of these already, but several of the factors that affect fruit bud initiation are this rate of shoot growth. If you have a in fact, this I think you also probably had this last quarter. If you plot this relationship of number of buds per node here, number of clusters per node. These are rudimentary clusters, the clusters within the bud. Number of clusters per node. Against shoot length. You find and this goes up to, I don't know, something like 8 feet. You find a maximum in this middle range here. In other words, you want shoots around 3 or 4 feet in length, and shoots that are very small tend to have fewer clusters per bud, and shoots that are very long tend to have fewer clusters per bud. So the rate of shoot growth affects the rate and the total length of shoot growth has an effect on the number of fruitful buds. Now, high nitrate and abundant water at the time of fruit bud initiation will reduce bud fruitfulness due to their effect on this rate of shoot growth. And you've also been showing the data that shows that low light intensity during this period of fruit bud initiation affects the number of clusters primordia per bud. In this growth chamber work that I showed you, there was a linear increase in fruit buds formed per bud with increase in light intensity. And low temperatures during this period of bud fruitfulness also affect the number of buds, the number of fruit buds, clusters per bud. And there was quite a difference there in the varieties. Some varieties, like the Thompson Seedless or the Muscat of Alexander, needed at least a temperature of 68 degrees to form a fruit primordia. Other varieties, like Riesling, could form fruit primordias down to temperatures as low as 59 degrees Fahrenheit. Overcropping is associated with low bud fruitfulness, and this is believed to be related to the ability for the vine to accumulate carbohydrates. Another factor that can affect fruit bud initiation is the amount of leaf area or defoliation. If you happen to have, for example, an infestation of leafhoppers or some insect that defoliated your vine during this period of fruit bud initiation, this will have a large effect on on the number of fruitful buds of the following year. And there's also work to indicate that the hormones themselves have a marked effect on the number of fruitful buds. The gibberellins are generally associated with reducing fruit bud initiation, and the inhibitors, the so-called growth inhibitors, generally promote fruit bud initiation. Inhibitors being examples of some synthetic inhibitors are the CCC or the B9, are two growth inhibitors that can be used to increase fruit bud initiation. And this has been done experimentally. People have gone through and sprayed on these inhibitors a couple weeks before bloom, just before the fruit bud initiation starts. And in fact, you can increase your fruit bud initiation by doing this. Now, fruit bud initiation, as we've mentioned, starts at about the time of flowering and continues for the next couple of months. The Australian workers claim that, though, that the most critical period of fruit bud initiation is that 4-week period immediately following flowering. And they've done a lot of work on this since their conditions seem to affect fruit bud initiation much more than our conditions. They found if they go through and artificially shade during that 4-month period, they can markedly affect the fruit buds that following year. If they shade after that 4-week period or before it, they have no effect on the fruit bud initiation. So at least under their conditions there, that 4-week period immediately following bloom is the most critical period for the fruit bud initiation. Now, I might just show you some of this data of where Winkler and his co-worker looked at where fruit bud initiation first starts and how it progresses. I think you might have gotten some of this information last quarter, but so that your notes are complete, I'll put a little bit of that data on the board again. Fruit, if we put on the board here the bud position, if we have a basal bud now, and say a middle bud on a shoot, and a terminal bud, and then we plot date here. This is June 7th, July 11th, July 22nd, August 22nd, and we'll jump all the way up to December 5th. And the number of fruitful buds were 3 here by June 7th. So that indicates, generally our flowering begins at about May 20th to June 1st. So that indicated that the basal buds, which in this case includes the buds up to node 3, the first 3 positions, there was about three buds being differentiated out of a total. This now is the number of fruitful buds differentiated out of a total of 20. So there was 3 out of 20 on June 7th, 7 out of 20 on June 22nd, 7 out of 20 on August 22nd, and there was 8 out of 20 on December 5th. Now this is for Thompson seedless vines now. And for the middle node position, this was a node position 8 here. There was 1 bud, 13 out of 20. There was 13 fruitful buds on July 11th, 15 on July 22nd, 15th on August 22nd, and 14 there. Now, these of course are not significant difference. So you can say that by the July 22nd, all the buds that were going to be differentiated into fruitful buds had occurred by the 22nd of July here at this 8th node position. The terminal node position, node 16, there was 0, 5, 10, 12, and 12. So all the buds that were going to be differentiated into that had fruitful clusters in them were differentiated by the 22nd of August here. And in this same work, they found that the nodes between 4 and 12 are the most fruitful, and they also have the largest clusters and the most number of flowers per bud, or between the 4th and the 12th nodes. Now, there's been some additional work in Australia showing the light requirements here for bud fruitfulness, and they've found now that in order to have a fruitful basal bud, or in order to form a fruitful cluster primordia, you must have that leaf blade in the sun as well as the bud at the base of that, as well as the bud at the base of that leaf in the sun. In fact, if you take a shoot, or if you take a cane and a shoot, and wrap that bud at the base of that leaf in aluminum foil and keep the light off of that bud during the entire season, it will invariably be a barren bud the next year, even though the shoot blade, or the blade of the leaf, is in the sun.
It will not?
So if it will not have a fruitful cluster primordia if you keep the bud, if you exclude all light from that bud during the entire season. In other words, if you wrap aluminum foil around that bud as soon as it separates from the shoot apex and keep all light off of that bud, it will be a barren bud the next year, even though the leaf blade is exposed to light. Now, you can do the other thing, and if you remove all light or keep all light off of the leaf blade, you will also reduce the fruitfulness of that bud at the base of that leaf. Is there a question?
Yeah, does this account for your basal sterility and toxins?
Yeah, this certainly has a very important factor that, and in fact, when we gave you that later data last lecture where we showed the sun canes, or canes that we've trellised out to be out in the sun during the entire season, you can increase that fruitfulness and its Indelia effect of better light penetration hitting that bud. Now, this data that I just told you about, these barren buds, were done with Thompson Celis. Wine varieties don't seem to be as critical in their light requirements. In fact, most wine varieties have fruitful buds along the whole length of the shoot. Even the basal buds will tend to be fruitful. Except if you get all the way out to the very tip, then these buds may have a little bit lower fruitfulness. But by and large, for most wine varieties, the buds are fruitful along the entire length of that shoot.
Would that be because the terminal buds would get less sunlight?
No, I think it's just... No, I don't think it's that. I think it's just that they haven't had enough time to accumulate carbohydrates at the... I'm talking about the very apex of the shoot now. They haven't had as much time to accumulate carbohydrates there as the basal part of the shoot.
Find out that we have an upright